All right, guys. So since we are virtual this week, I figured I would go ahead and record these lessons. As you know, though, you can get all the same information by going through the Apex study courses. Now, those are a little more interactive, give you some more examples that you can try out on your own. So it's up to you if you want to do the Apex study, if you want to watch these videos with me, or if you want to do both. Totally up to you. These notes will be in my live notebook though, either way, so you can copy them down. You already have this note guide, so that should not be a big deal at all. So we are going to do 3.2 today. We'll do 3.3 tomorrow or Thursday, and then your Friday assignment will be to do the review on your own, and make sure you bring that with you next time that we're in class, which will actually be March 1st, Monday, March 1st. And that'll be the last week that we have before spring break. I also figured, since I'm kind of spreading out this week a little more to give you some more room to get things done on your own, that for this week, your extra credit opportunity is simply just to get everything done on time this week. So if you get the 3.1 quiz done and the 3.2 quiz done, and you bring in that review sheet next Monday already done and ready to go, or at least done as much as you can figure out with questions ready to ask me, then I'll give you extra credit for this week. And then we'll be taking the test next time I see you after we've had a chance to kind of go over what you've learned. All right. So 3.2, in this section, we're going to talk about how to actually solve trigonometric equations. Okay. So this first one, we're going to solve this trigonometric equation. 2 cosine of x minus root 2 equals 0. And so we're going to solve for x. And we're going to use the same methods we've used since pre-algebra. We're going to multiply, divide, subtract, add to both sides of the equation to try to get x completely by itself. Okay, one difference now is that we have trigonometric functions in there. So we're going to have to talk about how do we get the trigonometric function out of there as well. So let's see. Let's go ahead and I'll just write down the equation down here. It says show your work, so I'm going to do that. 2 cosine of x minus root 2 equals 0. Okay, and again, we're trying to get x by itself. So the first step to getting x by itself is I actually need the cosine of x to be by itself. The very last thing I'm going to get rid of essentially is going to be the cosine part. So I'll start here by getting rid of this root 2. So the opposite of subtracting is adding. Add root 2 to both sides of my equation, and we end up with 2 cosine of x equals root 2. Okay, and then again, we got to get cosine x by itself here. So I need to get rid of this 2. And that 2 is being multiplied by the cosine of x. So I do the opposite to both sides, divide both sides of my equation by 2, and I get the cosine of x equals root 2 over 2. And I'm not going to change that to a decimal because that root 2 over 2 should look real familiar here. Cosine of x equals root 2 over 2. Let's go back to our unit circle. You should have a unit circle all over the place in your notes. This is kind of the extra sheet by itself that I gave you at the beginning of the semester. So remember, you should have this written down. The cosine of your angle is the x coordinate in the unit circle, and the sine of an angle is the y coordinate of the terminal point in this unit circle. So we just wrote down a second ago that the cosine of our variable we're trying to solve for, x, so the cosine of our unknown angle, was equal to root 2 over 2. So looking at this unit circle, where is the cosine equal to root 2 over 2? Meaning, where is an x coordinate equal to root 2 over 2? And I see two of them. I see an x coordinate here that's a positive root 2 over 2. And I see an x coordinate here that is a positive root 2 over 2. Okay, and with these things, there will always be two different angles. So looking at this, we can see the cosine of pi over 4 equals root 2 over 2. And we can see the cosine of 7 pi over 4 equals root 2 over 2. So those are our two solutions. So I'm going to come back here. So we said x, or here, I'll draw a picture for our notes. So there was here at pi over 4. This point was root 2 over 2, comma, root 2 over 2. And down here at 7 pi over 4, we had the point root 2 over 2, comma, negative root 2 over 2. So for both of these, the value of the cosine is root 2 over 2. So x can be either pi over 4 or 7 pi over 4. Okay, also, we just learned about inverse trigonometric functions last time that we were in class. So another way that I could rewrite this, we could say the inverse cosine of root 2 over 2 equals, and if you were to actually put this into your calculator, it would give you the answer pi over 4 in decimal form. Okay, 7 pi over 4 is another solution, but the reason, remember, that your calculator is only going to give you the pi over 4 option is because your calculator is automatically going to turn this inverse cosine into a function. And in order to be a function, you have to restrict the domain, which means it's only going to give you one of these two outputs. And the one that we end up with is this one because it's within the correct domain. Okay, so here is our answer. I'll write it this way. Ooh, hold on. All right, so our solution to all of them is x can equal pi over 4. X can equal 7 pi over 4. There's always 2. And remember, we also have coterminal angles, meaning that anytime that I rotate around 360 degrees, this unit circle, I end up back at the exact same terminal point again. So any additional rotation here would also be a solution. So I could say pi over 4 plus 2 pi, pi over 4 plus 4 pi, pi over 4 minus 2 pi. We can go in the opposite direction. So I do this plus or minus 2 pi n on the end of all of my solutions so that I am including every possible solution that would make my equation true. Okay, let's try another one. The sine of x minus root 3 equals the negative sine of x. All right. So again, the first thing I want to do is I want to get the sine of x by itself, meaning right at the moment I have two sines of x's, so I'm going to want to combine those on the same side of the equation. And then I'll get rid of the sine part. So let's see. Let's try to get the sines on the same side of the equation. I'll go ahead and just put them on to the left. So I'll need to add this one to both sides. Right? This is negative. So I add it to get rid of it. Whatever I do to one side, I have to also do the other side. So that gives us 2 sine of x minus root 3 equals 0. So now that all my sine of x's are on the left, I'll need to put this root 3 onto the right. So to get rid of a root 3, this is negative, so I will add it to both sides, which gives me 2 sine of x equals root 3. And again, we need to get sine of x by itself before I can undo that sign. So I'll divide both sides by 2 to get rid of this times 2 portion here. Whenever I do to one side, I have to do to the other side as well. So we end up with the sine of x equals root 3 over 2. All right. So at this point, I can grab out my calculator and say, okay, inverse sine of root 3 over 2 equals x. But again, your calculator is going to give you a decimal, not a fraction. And your calculator is only going to give you one answer when there are actually infinite answers. So the better thing to do in this situation would be to recognize root 3 over 2. In your unit circle, we know the sine is equal to the y coordinates of our terminal points. And the two places where I see a terminal point with a y coordinate of root 3 over 2 is here and here. Take a second to look at your unit circle and find the points I'm talking about. This point is 1/2 root 3 over 2. And this point is negative 1/2 root 3 over 2. So both of them have a y coordinate or a sine value of root 3 over 2. This angle is pi over 3. And this angle is 2 pi over 3. So again, if I were to put this into my calculator, it would give me the pi over 3 as a decimal. Okay, it only gives you one of those two answers, and it does not give you any coterminal points. So if you put that into your calculator, it'll give you this answer, pi over 3 written as a decimal, which is, I'll just tell you real quick, pi divided by 3 as a decimal is 1.047197551. Okay, so you'd have to then translate that to pi over 3. Okay, but that's not the only answer. The other answer is 2 pi over 3, as well as every other coterminal angle. So our solutions, x can equal pi over 3, which actually, if we wanted just one answer here, if we wanted the answer for the function, that would be the only one we would give. But for the relation, there are multiple answers. It's pi over 3, as well as 2 pi over 3, and every coterminal angle of those two angles. So I will add and subtract a 2 pi n, every multiple of one rotation, to each of those solutions. So all of these are solutions to that equation. Again, if we only wanted one, because if we were looking at a function of sine rather than a relation of sine, the only answer we would give is this one, because this is the one that is within the domain of sine. And if you look back at the last section, 3.1, you can see what the domains of our different trig functions were, so you know which of these solutions you would need to select. For the most part, it's pretty much always going to be the solution that's in that first quadrant of our unit circle. Pretty good rule of thumb. All right, moving on. Let's try this one. The solution to this trigonometric equation is, and you can see they give you 1, 2, 3, 4 places to put your answer. So let's see what happens here. So I'll write the equation first. Half cosecant squared x minus 1 equals 0. All right, so this looks interesting. I got a cosecant squared here. Let's go ahead and just approach it the same way though. I'll start by getting the cosecant squared by itself. So I'll need to get rid of this minus 1. Opposite of subtracting is adding. So add 1 to both sides. Oops, trying to get these extra marks. Come on, eraser, there it is. And that leaves me with 1/2 cosecant squared x equals a positive 1. Okay. Next, I need to get rid of this 1/2 here. Remember, this is 1/2 times the cosecant squared of x. So to get rid of it, I'll have to multiply both sides by 2 or divide both sides by 1/2. Same thing, right? So if I multiply both sides here by 2, you can see the 1/2 and the 2 here cancel out. 1/2 times 2 is 1. So we're left with just the cosecant squared x equals 2. All right, now from here is where we have something a little bit new. So the next thing I have to get rid of is actually the square on our cosecant. So how do we get rid of squares? Well, the opposite of squaring is square rooting. So we square root both sides. And when I square root both sides, I have to say the square root of 2 can be positive or negative, right? The square root and the square, though, on the cosecant do just cancel out. So we're left with just the cosecant squared x equals a positive or negative root 2. Oops, I forgot to take off the square. I said it canceled and then I didn't cancel it. There we go. All right. So the cosecant of x is equal to a positive or negative root 2. Remember, the cosecant is the reciprocal of the sine. So I could change this into a sine. I could say the cosecant of x is equal to 1 over the sine of x, which means that the sine of x would then be equal to the reciprocal of positive or negative root 2. So 1 over root 2. At this point, that should be looking super familiar. Okay, remember back in the first unit this semester, we encountered this sine value, sine of an angle that equaled 1 over root 2. And when we rationalized 1 over root 2, we got root 2 over 2. So we are looking at the sine of an angle that equals root 2 over 2. So what is x if the sine of x equals root 2 over 2? And again, I could use my calculator. I could say the inverse sine of a positive and a negative, I'd have to do two separate ones, root 2 over 2 equals x. But again, it's only going to give you one out of two solutions, and it's not going to use any coterminal angles. It'll give you a decimal, not a fraction, and it won't use pi. So there's some restrictions there. With a multiple choice test, we can work with that though. It's a good way to check your work. So let's go ahead and look at our unit circle. So we're looking for the angles in our unit circle that have terminal points where the sine, or the y coordinate, is either a positive or a negative root 2 over 2. Okay, and there are actually several. So I have a positive root 2 over 2 here and here. This point is root 2 over 2, root 2 over 2. And this is at the angle pi over 4. So pi over 4 is one solution. This angle, or sorry, this point is at root 2 over 2, negative root 2 over 2. So its sine is a negative root 2 over 2, and its angle is, it's 7 pi over 4, I think. Where am I here? Yeah, 7 pi over 4. So 7 pi over 4 is a solution to this equation. And we also have one here. This point is negative root 2 over 2, positive root 2 over 2. So the sine is a positive root 2 over 2 at this angle is 3 pi over 4. So there's a third solution. And we have one here. This terminal point is negative root 2 over 2, negative root 2 over 2. And its angle is 5 pi over 4. So we have a total of 4 solutions here, plus all of their coterminal angles, which makes it an indefinite number of solutions. Again, so the reason why we end up with 4 initially is because there were 2 values of this sign, right? So we have 2 for the positive root 2 over 2, 2 for the negative root 2 over 2, and then we have the coterminals of all 4 of them. So my solutions, I would say, are, we have our initial one, pi over 4, plus or minus 2 pi n, because those are the coterminals. And you're going to notice a lot in this section, they kind of leave off the coterminal thing here. It's kind of just assumed in a lot of cases. So if you just write pi over 4, that is an answer. So that is fine. Just know that any additional 2 pi would be okay as well. Okay, the next one I have on here, 3 pi over 4, plus or minus any 2 pi n would be okay. 5 pi over 4, plus or minus any 2 pi n, and 7 pi over 4, plus or minus any 2 pi n. Okay, So being aware of those coterminal angles is important. Again, you'll probably have checkboxes for these questions. So you would check the box that would have pi over 4. You would check the box that would have 5 pi over 4, 3 pi over 4, 7 pi over 4. But you'd also have to check a box like maybe 9 pi over 4. That would be 2 pi over 4 plus 2 pi. So just be aware of those things. You might have to play with your fractions to make sure that you don't miss one, okay? All right, next, let's look at this one. This one's a lot different. So on this one we have, right over here, the cosine squared of x times the sine of x minus 3 sine of x equals 0. All right. Okay, give me 1 second. Oops. All right, so on this one, you can see right away we got some trouble because there are 2 different trig functions in here. So we're going to talk about a couple of different ways that we can work with equations that have more than one trig function. In this one, we can solve this one fairly easy by factoring. Okay, notice in this equation, I have 2 terms on the left-hand side being subtracted from each other. This is one term, this is another term. And notice those 2 terms have a common factor. There's a sine of x on this one, and there's a sine of x on this one. So I can factor out the sine of x. So on this side, I would have, so when I factor a sine of x out of this first term, I'm left with cosine squared x. And when I factor a sine of x out of this second term over here, I'm left with just this minus 3. All right, so now that we have this factored, you should notice we have something, the sine of x times this thing here equals 0. Well, we know a lot about multiplying things and getting 0. Remember from algebra 2, the 0 product property says anything times, if something times something else equals 0, then either one of those factors equals 0, or the other factor has to equal 0. So we're basically solving this like it's a quadratic equation. We got everything equal to 0, it already was, factored it out, and then set each factor equal to 0. So now I went from having one equation to having 2 equations, but we're actually a lot closer to getting our answers. So let's start with this one, the sine of x equals 0. So the sine of what angle equals 0? Again, you could grab your calculator out real quick and do the inverse sine of 0 equals, and it'll give you x. But again, it's not going to give you fractions. It's not going to give you any coterminal angles. It's only going to give you one answer. So we have to be careful of that. So let's look real quick at our unit circle. The sine is our y coordinates. Where is the sine equal to 0? That would be here and here. Here the point is 1, 0, and here the point is negative 1, 0. This angle is 0 radians, and this angle is pi radians. So there's 2 answers, 0 and pi, as well as any additional rotation. Let's see what we get from this one. Let's solve for x. So I'll add 3 to both sides to get rid of that minus 3. And then to get rid of the square here, I'll have to square root both sides. And when I square root this 3, I have to say positive or negative. Oops, root 3. But the square and square root do cancel out, so we just have cosine of x. So I have the cosine of an angle equals a positive or a negative root 3. All right, so at this point, you can look at your unit circle, but you're not going to find any x values that are root 3, so that doesn't help. So we can use our calculator. The inverse cosine, I'll start with positive root 3, and then we'll do the inverse cosine of a negative root 3. We're going to do both. And so you put that into your calculator, make sure you're in radian setting, and it'll say, I believe it says air domain. Let me just check and see what my calculator says exactly. Inverse cosine of the square root of 3. Yep, it says error domain, both times. Error domain. Okay, it's giving you an error because root 3 is not in the domain of cosine. Okay, remember back from the first unit that we did, the cosine, the value of the cosine, or the domain of cosine, is always between -1 and +1. The square root of 3 is greater than +1. So we cannot, there is no angle with a cosine value equal to a root 3. It's impossible. There are no solutions on this side of the equation. So that means our only solutions are here at 0 and pi in every terminal of that. So think of that though. If I take 0 and add and subtract 2 pi, that's going to give me 2 pi, 4 pi, 6 pi, 8 pi, all of my even pi's, right? If I do the same thing to my other solution, pi plus or minus 2 pi, n, I guess, that would give me pi, 3 pi, 5 pi, 7 pi, 9 pi, all of my odd pi's. So if I have all of my even pi's and all of my odd pi's, that's just every multiple of pi. So we can actually combine these this time, which maybe isn't that necessary, and just say it's every multiple of pi. 0 pi, 1 pi, 2 pi, 3 pi, and so on. So we were able to basically combine our two solutions here into one solution. It's every multiple of pi. All right, let's look more at these trigonometric equations that model a quadratic type function. So we'll label this here. Call this the quadratic approach. We do this quite a bit. So it'll be good if you can find it. All right, so on this one, we are given secant squared x plus secant of x minus 2 equals 0. All right, so if you notice, this equation is very close, very similar to a quadratic equation. In fact, if I went ahead and said, let's let the secant of x equal, I don't know, b. And then I rewrite this equation, it would look like this. B squared plus b minus 2 equals 0. That's a quadratic equation. We know how to solve this from algebra 2. To solve a quadratic equation that's already equal to 0, I can factor, or I could use the quadratic formula. So let's go ahead and solve this just like the way it looks. Let's use factoring though. What are the factors of -2 that add up to +1? I see that would be +2 and -1. Yeah? And now we know something times something else equals 0. That means either this factor equals 0. Oops. Which means b equals a -2. Or this factor equals 0, which would mean b equals 1. Cool, we got some solutions. let's back up now and remind ourselves that b in this case, we said b equals the secant of x. So let's go ahead and put that secant of x back in there. B is the secant of x. B is the secant of x. All right, so we're not actually done solving for x. We still have some more steps to do, but we're pretty much almost done with our solution now. We're right at the end. So again, I could go ahead and put this into my calculator at this point, but it's not going to give me fractions. So I'm going to go ahead and do it by hand looking at my unit circle. But the unit circle only gives me sines and cosines. So let's remind ourselves here. The secant is the reciprocal of the cosine. So if the secant of x equals -2, then the cosine of x will equal -1/2. Same thing over here. The secant is the reciprocal of cosine. So if the secant of x equals 1, then the cosine of x equals 1/1, which is just 1 still. And then I can go ahead and look at my unit circles. So where is the cosine of x? Where is the x value equal to -1/2? That would be here and here. This point is -1/2 positive √3/2. This point is -1/2 negative √3/2. Okay, and this angle here is 2 pi over 3. And this other angle is 4 pi over 3. So there's two solutions, 2 pi over 3 and 4 pi over 3, as well as all of their coterminal points. I'll go ahead and add that to my answers up here. 2 pi over 3 plus or minus 2 pi n. And 4 pi over 3 plus or minus 2 pi n. Now let's look at our other set of solutions. When the cosine of x equals 1, when does the cosine or x coordinate of a point equal 1? Actually, only one time, right here. This point is 0, 1, and this angle is pi over 2. So our last solution is pi over 2 plus or minus 2 pi n. Okay, so I do want to say too, if you go over the apex stuff, I don't think they do the substitute for b in here, but in my experience, especially when you're first learning about this, substituting b for the trig equation that you're given makes things more, it makes things simpler, easier to look at. If you can recognize how to factor out this equation without doing that, that's totally fine. I just find in my experience, usually when I do this, it makes a lot more sense for my high school students. All right, let's try another one. Okay, so in this one, we're going to apply a few things to this. So let me write it down first. We got -2 sine squared x minus the cosine of x plus 1 equals 0. All right. So again, the first thing we notice, we have sines and cosines here. That's not good. Okay, we can't solve for x when there's both sines and cosines. I need them to be all the same trig function. So I need to either change a cosine to a sine, or I need to change a sine to a cosine. All right. Or also we saw on the last page, we were able to kind of factor one of them out. But not all of these, none of these terms have any common factors. So my terms are -2 sine squared x, negative cosine of x, and positive 1. They don't have any common factors. So we can't do that method again. So instead, I got to figure out some way that sine and cosine are related. And we actually already related cosine and cosine in a previous section. There was a rule called the Pythagorean theorem for trigonometry. Let's go ahead and recall what that was over here. Oops. We're going to use this rule here a bunch from here on out. So you're going to start remembering it real quick. So the trigonometric Pythagorean theorem was the sine squared x plus cosine squared x equals 1. Okay, y squared plus x squared equals r squared in our unit circle, basically. And we can manipulate this equation a bunch to get different variations of this. I could subtract sine squared from both sides. So we have cosine squared x equals 1 minus sine squared x. I could subtract cosine from both sides. So we end up with sine squared x equals 1 minus the cosine squared x. And then we also had some variations, and we learned about this previously, where we would take the original sine squared x plus cosine squared x equals 1. If you divide everything here by the sine squared x, we got 1 plus cosine over sine is cotangent equals 1 over sine, which is cosecant. And then we could do the same thing that we did here. Again, we could subtract from both sides, add to both sides, and get different variations of this. And there was another variation that we talked about before. If I go back to my original Pythagorean theorem and divided everything by cosine squared of x, we ended up with sine squared times divided by cosine squared is tangent squared x. Cosine squared divided by itself is 1, and 1 divided by cosine is the secant squared of x. And then again, I could add and subtract 1 from both sides, change it up a little bit, but we end up with, again, lots of different variations. With this here, I can relate sine to cosine. So given a cosine equation, I can substitute it with a sine equation and vice versa. Here, if I have a cotangent equation, I can substitute it with a cosecant equation. And here, if I have a tangent equation, I can substitute it with a secant equation and vice versa. So let me show you how that ends up looking with this example over here. And let's go ahead and just, all right. So let's go ahead and show you how we can use that to our advantage here. Notice we have this sine squared of x right here. And I need to either change the cosine to a sine or the sine to some sort of cosine. So since I have a sine squared x, and over here I see lots of different sine squared x's, I'm going to go ahead and use this. The sine squared x is equal to 1 minus cosine squared x. That means I can substitute sine squared x with 1 minus cosine squared x. So it looks like this. So all I did was replace this sine squared x with 1 minus cosine squared x because they are equivalent. They are equivalent expressions are equal based on the Pythagorean theorem. And now I have an equation that has one type of trig function. Perfect. So now we can work with this. So I can see I have a squared term and a couple other terms in here. So we're looking at maybe quadratic. Let's go ahead and distribute this -2 out here. -2 times 1, -2 times negative cosine squared, minus cosine x plus 1. And we can combine some like terms here. I can't combine the cosine squared with the cosine because they have different powers, but I can combine this -2 with that positive 1. So let's do that real quick. -2 plus 1 is -1. There we go. Okay. And now this is the point where you can see this looks like a quadratic equation. Okay. And if you have trouble seeing that, go ahead at this point and say, let's let b equal our trig function cosine of x. Then this becomes 2b minus b, or 2b squared minus b minus 1 equals 0. So it's a little easier to see at this point, and I change that out, that this is truly a quadratic equation. And at this point, I can use either quadratic formula, or I can try to factor this. So let's see if we can factor it, because usually factoring is a little faster, if it's possible. So let's see, I do have a 2 out in front here. I know the factors of positive 2 are definitely going to be positive 2 and positive 1. And then I have a negative 1 here. I know the factors of negative 1 are definitely going to be positive 1 and negative 1. So let's see, where should I put the negative 1? Which side? So that I end up with a negative b here. I probably want the 2 times negative 1 and the 1b times positive 1. Double check that. If I FOIL that back out, I get 2b squared, positive 1b, negative 2b, which gives me the negative b in the middle, and 1 times negative 1 is negative 1. Perfect. Okay, so now we go ahead and say, all right, this times this is 0, so either this one is 0 or this one is 0. If it's this one, then we subtract 1 from both sides, divide both sides by 2, I get negative 1/2. Over here, add 1 to both sides, I get 1. Cool. So now let's go back up. We said b was the cosine of x, so we should probably put that back in. The cosine of x equals negative 1/2. The cosine of x equals 1. All right. And again, at this point, I can put this into my calculator, or probably the better option, considering these involve ratios of pi's and whatnot and different answers, is use your unit circle. So let's start the first one. The cosine of x equals negative 1/2. Where is my cosine? Negative 1/2. Let's see. I see here at 2 pi over 3. This point is negative 1/2, positive root 3 over 2. And down here at 4 pi over 3, I see this one is negative 1/2, negative root 3 over 2. So there's two solutions, 2 pi over 3 and 4 pi over 3. Let's add those up here. 2 pi over 3 plus or minus 2 pi n, and 4 pi over 3 plus or minus 2 pi n. And lastly, let's go to our other set of solutions where the cosine of x equals 1. Where does our cosine equal 1? Only right here at 1, 0. And that is, of course, 0 radians. So 0 plus or minus 2 pi n, which we can just write as plus or minus 2 pi n. And that is it. Actually, I would write 0. Oh, whatever. Where are we at? Last page of examples. Remember, if you have any trouble with this stuff while you're doing it, let me know. You can email me. You can jump on Zoom. I'll try to keep Zoom open all day, all week. If I'm not, though, it actually sends me a notice if you jump on Zoom and I'm not already there. It sends me an email. So I know that you're waiting on me, okay? So don't worry about it. Let's see this one. The solution to the trigonometric equation, this. So let's write it down. Sine of x plus 1 equals the cosine of x. All right. So again, I have a trig function with both sine and cosine. I know I can't really solve a trig equation with two different trig functions in it. I have to get either the sine turned into something with cosine or the cosine turned into something with sine. And we had in the last page, we have all of these fun ways that sine and cosine are related, so I can substitute one for the other, but they all have squares. My equation at the moment doesn't have any squares. So let's change that. Let's go ahead and square both sides. We can do that. Yeah? So now on the right side, I have cosine squared x. On the left side, though, we have to be careful. Remember, when I square this binomial here, there are two terms. We can't distribute an exponent. I have to FOIL this. This is the sine of x plus 1. I'll rewrite it this way. Times itself, the sine of x plus 1. So I'm gonna have to FOIL that out here, which isn't a huge deal. You've done it a million times before. So I'll do first times first. Sine x times sine x is sine squared x. Our outer is sine of x times 1, and our inner is also sine of x times 1. So that gives us 2 sine of x. And last, 1 times 1 is positive 1. Okay, so at this point I still have sines and cosines, but now they're squared. So I can go ahead and take this cosines all by itself. I can replace that cosine expression with a sine expression. So let's go back up and look at what we had. We can replace, get that out of my way, there, maybe. All right, so I can replace the cosine squared x that we have with this expression, 1 minus the sine squared x, and then I'll just have sines. So let's do that. So I'll replace that with 1 minus the sine squared x, because that's equal to the cosine of x, so we can do that. So now I have this expression. All right. And we know at this point it's looking somewhat quadratic, but I got to have all my signs on the same side, and I should actually have it equal to 0 if I'm going to solve a quadratic type equation. So I need to subtract the 1 from both sides. I need to add the sine of x from both sides, or sine squared x to both sides. And that gives me 2 sine squared x plus 2 sine of x. Oops. Positive 1 minus 1 is 0. Cool. Equals 0. All right. Now, so again, at this point, I can pretty much treat this as a quadratic. If I need to, I can replace the signs with like b or something to make it a little easier to see. But I am seeing right away that my 2 terms here have multiple common factors, actually. They both have sine of x, and they both have 2. So let's factor out a 2 sine of x. So when I factor out a 2 here, the 2 goes away, we're left with just 1. When I factor out the sine of x here, sine squared x divided by sine of x is sine of x, right? And on this side, 2 sine x divided by itself is 1. Got kind of a lot of space there. Let's fix that. There we go. All right, so now that I have my quadratic equation factored, I can go ahead and say, okay, if this times this equals 0, then either this equals 0 or this equals 0. And solve them separately. So on this side, divide both sides by 2. 0 divided by 2 is still 0. On this side, subtract 1 from both sides. Get negative 1. Okay, and then at that point, I can put both of those into my calculator, or just look real quick at my unit circle to see if those values happen to be on there, and they are. Let's see, the sine of x is 0 here and here. This point is 1 comma 0, and this point is negative 1 comma 0. And of course, this is 0 radians, and this is pi radians. On this side, let's see, sine is negative 1 in one spot. Right here. This point is 0 comma negative 1. And it is at 3 pi over 2 radians. So those are my solutions. I have, and remember with this one, with this solution, every rotation of 0 is going to give me all of the even pi's, and every rotation of pi will give me all of the odd pi's. So this just gives me altogether all of the different multiples of pi. So we'll say pi n, as well as on this side, we have 3 pi over 2 plus every rotation. 3 pi over 2 plus or minus 2 pi n. And last example. All right, so I'll write down the equation first. 2 cosine of 7x plus 1 equals 0. All right, so it looks pretty straightforward so far. There's only one trig function in cosine, and there's only one term with cosine in it. So let's just use our inverse operations. I'll subtract 1 from both sides. So I get 2 cosine of 7x equals -1. And then I'll need to get rid of this 2 here, which is being multiplied by our cosine of 7x. So I'll divide both sides by 2 to get rid of it. Excuse me, the cosine of 7x equals -1/2. Now at this point, you see something that we have not dealt with before. Okay, I have the cosine of an angle equals -1/2, but that angle is 7x. So at this point, I'm going to pause, and we're going to just solve for this angle as a whole, and then we'll divide it by 7. So I'm going to go to my unit circle and say, okay, where is the cosine equal to -1/2? Let's see, the cosine is equal to -1/2 here at 2 pi over 3, and here at 4 pi over 3. So that angle, 7x, could equal 2 pi over 3, or that angle, 7x, could equal 4 pi over 3. So now that we've actually found those angles, we actually have one more step. We need to get x by itself. So divide both sides by 7. Divide this first one, both sides by 7, you get 2 pi over 21. And divide both sides by 7 on this side, we get 4 pi over 21. Okay, to divide a fraction by a number, you just multiply it by the denominator. So we end up with these two solutions, plus or minus 2 pi. 2 pi over 21 and 4 pi over 21. And I think that is it. Okay, so I will post another video for 3.3. And remember, if you get all of your work done this week on time and you come to school ready to go on March 1st, I will give you some extra credit. So make sure you are getting it done, being productive. And if things get difficult, if you get stuck, reach out, let me know, ask me for help. I'm here for you.